Good evening, everybody. This is MySec Southfield, and everything just full screen for no reason on my screen.
Oh, I went to
Oh,
uh,
okay.
present.
So MySec Southfield meets on the second Thursday of the month, same as Grand Rapids. Other chapters we have, if you're tuning in from the internet, we have MySec Jackson on the second Tuesday of every month, and we have MySec Lansing and Detroit on the second Wednesday of every month. Other meetups you might be interested in, ISC Squared meets on the fourth Tuesday of the month. The North Oakland ISSA meets on the second Wednesday. Motor City ISSA and Lansing ISSA meet on the third Thursday. We are currently meeting in a Zoom chat as hosted by Uber Ether. Thank you for providing us space here. If you're having bad service tonight with any of the food or drinks that are happening, that is your own fault. Maybe rethink your life decisions on that front. We are not going to be closing the bar at 8 tonight, which means that we have more time for the talk than we normally would. So, the exclusive content that you cannot see in person is happening tonight. If you would like to be a part of MySec, if you have a topic for a talk or a workshop, let me know what you'd like to see. You can reach me on Twitter at tacoman_x86, or you can talk to me at the MySec Slack. If you would like to give a talk or help with the workshop, also see me. We're currently still looking for people who would enjoy writing about security, who can post blogs on the MySec website. If you have not joined the Slack, check it out at mysec.us on the page. So that is all I have tonight, unless anybody has any job postings that they want to announce before we get into it. Okay. So tonight we have James Green speaking about Intro to Web App Pen Testing with the OWASP JuiceShop. James, go ahead and take it away.
Right, cool, thank you. Just to make sure you guys can all see the slides, and if I change my screen like this, you guys see Callie, right? Yes, no, maybe
It's
so.
muted. Yeah, it's working.
All right, cool. Thank you. All right, so like Sam said, I'm going to go through a quick introduction. I've got some slides on how I got things set up, and then near the last half of the talk, we'll actually go through and exploit some of the examples as we talk about them. So the agenda for tonight, again, I'm going to kind of tell you guys what JuiceShop is, talk a little bit about OWASP, and explain the setup that I'm using for doing this so you guys can recreate it. And then I'll talk about penetration testing itself, basically what it is and how to do it for web applications. And then we'll go through the vulnerabilities and exploiting them. If you guys have any questions, type it into Zoom chat. We're also streaming this on YouTube, so I think Sam or someone else that's on the Zoom call can look at the YouTube comments and just repeat them for me.
Yeah,
I
I'll keep
don't
an
have
eye out.
that chat window up, so we'll try to respond to comments as quickly as we see them come in, but this is kind of a work in progress, so we'll see. Shameless plugs. My name is James Green, GreenJam94 on Twitter. Feel free to follow me and I'll follow you guys back. I have a blog at hackerunder.dev. So try to post some of the projects I work on. How do I say that? I'm a developer at Offensive Security. So I work with them to build some of the interfaces that you see while you're using our products. I have to include this in here. This presentation does not include the views of my employer. I'm not building this off of any kind of course material or material that OffSec provides. This is just things that I've found through working with OWASP or finding resources online. So I had to cut a lot of slides out. I'll try to go over this quickly. What is OWASP? It's the Open Web App Security Project. Probably everyone that's on the Zoom call has seen experience with them before or worked with them. We have a local chapter, which is OWASP Oakland. Definitely recommend checking that out. OWASP is a nonprofit foundation that works on secure coding. They have a lot of projects online that either help you, fix vulnerabilities, how to find them, test them. They also have tools and training material like the JuiceShop hosted. So For me personally, it's a library of information. There's so much that I've learned over the last 5 years from the resources that OWASP has. Uh, it's a training environment. They have things like Matilda, the damn vulnerable web app, and JuiceShop that everyone can download on their own computer, get it up and running, and start learning how to do things themselves. And then it's also a community. Like I said, thanks to OWASP Oakland, there's a great group of people that you can meet up with locally. There's local chapters all around the globe. So highly recommend you reach out to somebody and try to see what's in your area. So our setup for tonight, to get JuiceShop up and running, I'm using Docker. You can pull the image right from the online repo. All you have to do is run these 4 commands. So installing Docker, it's a bit trickier than one command, but quick to do. You run docker pull JuiceShop, you'll get that installed, and then you just have to run the container. So run and set a port redirection on port 3000. So when you go to localhost 3000, you're actually hitting the container. And then browse that in your browser and you'll be able to see it. An alternative to this, if you don't want to install Docker or you don't want it running locally, is you can set it up on Heroku. It does require a free account, but there's a one-click deploy on the project's GitHub page, and you can, set it up really quickly. The hardest thing is probably just signing up for an account. One thing to say about that, though, is if you are doing it on Heroku, just be aware that it's a secure by obscurity type setup. If you share your URL with anyone or try to do it as a team, if someone else does a challenge before you do, everyone else gets the success message. So if you're trying to do everything yourself, I suggest, just not telling anyone else your private URL, have everyone do their own instance. Also, to help demonstrate this, I'm going to be running Kali on a virtual machine. You don't need Kali to hack the JuiceShop or do any kind of web app pen testing. It just helps because there are certain tools. As far as running Kali, I'm running it with bridge networking so that the VM can talk to my host machine and see that IP address with a port 3000 mirroring. I'm also going to be using Firefox to look at the web application, and then I'm using Burp Suite as my proxy tool. Now, Burp Suite isn't the only proxy that comes on Kali. It's not the only one you can use. There's also OWASP Zap, the Z attack proxy, that does the same thing, where it captures all the web traffic between you and the application that you're testing, and that helps you see individual packets, modify certain things. You can, repeat requests, do some online brute forcing, that kind of things with these proxy tools. Also, another reason I'm using Kali is just because it has more tools that we can use. So Dirbuster for doing some more enumeration, Hydra if I wanted to do hash cracking, anything like that. So it's just, there's more stuff available to me running on Kali. In personal opinion, I think it looks better than just running a default Windows setup or running on Mac. Also, I should say that we're not going to be looking at GitHub or the OWASP pages to learn about the application itself because there are spoilers. The JuiceShop has a complete documentation section that also includes the answers, and there's hundreds of walkthroughs posted online as people do it themselves. So if you're going to do this yourself, I suggest you don't look at the answers and try to figure out what you need to do just by looking at the scoreboard and trying to decipher what the challenges actually want you to do. Cut out the slide, so I'm just going to say it here before I move forward. We're looking at OWASP JuiceShop. It's a application written in Node.js and Angular. It's got an API, it's got RESTful requests, so it's more of a modern web application. It's not just a couple HTML pages or an old like PHP-based website. So it's definitely newer, and it still has all of the OWASP top 10 vulnerabilities that we'll be trying to find on the application. It's created by Jorn Kimmich, I believe is his name. I think I might be saying that wrong, but I'm trying. And the repository is hosted on his GitHub. So you guys can check that out afterwards if you don't want spoilers. Okay, so jumping straight into what is web app pen testing. Try to get through this quickly so we can go to the fun stuff. Before you do anything, there's two important things that you really want to make sure you have. It's scope and permission. So again, scope is seeing what's allowed or not while you're doing web app pen testing. Uh, it's not a complete list here, but just important things that you want to remember to look at. Talk to the application owner before you do testing and see what you should not do. So for example, if there are certain subdomains or other domains outside of the application, you want to see what's okay to hit or not. If there's a like admin.example.com, are you allowed to hit the admin site or is that blocked off? If there's a second domain that the company uses, so for example, there's like offensivesecurity.com and cali.org. Do you want both websites being tested or not? Stuff like that. Just see what's allowed, what you should be looking at, and what you shouldn't. Another thing with the web apps is if you want to be doing online brute force attempts. So this means, spamming their servers with tens of thousands of requests to see if you can guess a password. A lot of the times you shouldn't do this just because a high number of traffic could bring the server down if they're not prepared for it. So just see what's allowed or not if they want you to do any kind of throttling. Also, if it's more of a full pen test, if there's social engineering involved, like calling up their support department and asking if they can reset an account for you, pretending to be somebody, try to get in, say your company credentials aren't working and you need a new account. If you can get someone to help you, that's part of a pen test, but not really part of testing the application. So it all depends on the scope. Also, if there's any third-party vendors, for example, if they're using Google OAuth for user identification, logging in, logging out, you want to see if that's something you should be testing or not. Most of the times, like paid for providers, third party, stuff like that, you wouldn't be testing in an application because they probably have their own testing. But just get all that in writing, figuring out what you should or shouldn't do. And of course, when it comes to permission, you're spending all this time talking to the client, understanding the scope of it all. You want to make sure you get written permission saying you're authorized to do these kind of tests. If it's on a bug bounty platform, all this is normally written out in a certain format. So you have this kind of scope and permission already written out for you. Most of the time, if you're doing some more heavy pen testing stuff like brute forcing and all that, you can get in trouble for doing that if you don't have authorization. So just make sure you have all your T's crossed and your I's dotted before you get started. All right. I also took out a slide for saying different types of web applications or web app pen tests. If you've ever heard of white box testing versus black box testing, that's basically what I'm going to talk about. White box is when you have all the information provided for you. So you can see the source code of the application. You can see certain user accounts if that's provided, all that's provided up front, and you're just testing the logic, seeing if anything's exploitable. It definitely cuts down on the reconnaissance time, trying to figure things out because you know exactly what's being used and where. Black box testing is when you have no information provided whatsoever and you need to find information online. You have to crawl through the application, figure out what the functionality is, and try to see what the browser is telling you about the application. You're relying on all your own reconnaissance to, find out what you can do. In the middle between those two, there's something I call gray box testing. So gray box is just when you have some level of information given to you. For example, if you have a website or web application that you're testing that's meant for company users to use, you might need to start with a initial account to get in there. If you can't just register an account freely, they probably give you a place to start and move forward. So some information is provided, but not everything that you would get in a white box test. Okay, also when you're doing a pen test, it's important to find a methodology that works for you. There's many diagrams and processes that are available to you. To keep it short for tonight, I'm really just going to talk about three. If you want to find out more in-depth steps, you can check out, Rapid7's web app pen testing sheet. They've got a PDF online. Or again, look at OWASP and see all the information that they include on a web app pen test cheat sheet. That's got pages upon pages of things that you can include while doing a penetration test. For tonight, I'm going to focus on reconnaissance, testing, and recording. So when you're doing reconnaissance, this is when you uh, are trying to find information about the application and just figuring out how it works. You're not exploiting anything. You're not assuming there's vulnerabilities. You just want to know the type of information that's provided or taken on the application, the type of technology stack you're using, and moving forward from there. Testing is when you actually use the information from the last step. You try to see if there's a vulnerability and attempt to exploit it. And then recording is, again, taking notes during the first two steps and then writing up a report afterwards. You want to make sure you're very clear with writing up how you did all the exploits for the vulnerabilities so that when you turn in your report, the client can repeat all the steps for you or for themselves and use that for when they're seeing how much of an impact there is from the exploit. So the slides from the Recon, cool. So again, when you're doing reconnaissance, so learning about the target, what's the application's purpose, what the tech stack is, like I said, what inputs there are, and then how the data is used. If it's being stored, if it's just redisplayed on the next page of the application, all that stuff should be taken into account. A good tip and trick that I learned from doing a lot of CTFs is that you want to check for some common files when you're starting out. So two that I find really important is robots.txt. This is a file that informs robots, normally search engine crawlers like Googlebot, what parts of the website to index or to ignore. Most of the times, if you see a directory or a certain file listed on the robots.txt file, that's a dead giveaway that even though it's saying, hey, Googlebot, do not look at this, you as a hacker definitely want to look at that. So look at that first before doing anything else. As well as robots.txt, there's also a newer file that's called security.txt. This is normally where you have the contact information for people that are responsible for disclosing vulnerabilities or showing reports. So if this was more of an open platform, if someone has an open, it's okay to test our application, just send us the reports before, actually doing anything malicious. This is where that contact would be, and you would have other information, like maybe defining the scope or things that you are or are not allowed to do. Security.txt is a place to find some of that information. Also, when you're, doing reconnaissance on an application, it's important to enumerate the happy flow. What I mean by that is if you're looking at an e-commerce site, go through browsing different products, try to put stuff in a cart, try to modify the quantities of things, try to go to the checkout page, type through things. You don't have to actually buy anything or finish it, but just click through as many of the pages as you can to see how the application processes everything. Try to be a user. Don't try to hack it right away. Just understand what the application is supposed to be doing. And of course, while you're doing all this, note down anything that seems funny, anything that you have seen in the past in other challenges, or things that just might be worth looking at later. So I'll show some of that as we do this live. All right. So this is when you guys all see my password. All right. First off, I'm going to show you what my setup's going to look like. So for taking notes, I'm just using Joplin right now. So I'll put everything on one page just to make this easy as we go quickly. We're going to have a reconnaissance section and a testing section. Just doing this as notes, so I'm not going to have a report section until I finish everything up at the end. Probably not going to show that tonight. For looking at the application, again, this is Firefox. So going through all this, we have the application itself. The URL is already up here. Before I start clicking through things, I'm going to spin up Burp Suite and set up that proxy just so we start recording all the web traffic. Click through all this. It's just going to be a temporary project for tonight. I'm not going to save this. I'm not going to update using default settings. In order for the browser to send things to the proxy, you need to make sure you set up the preferences. So we're going to go back to Firefox. preferences, type in proxy. And I did that quickly. All right, so I normally just use the manual proxy configuration, set everything to my local host. That's where Perf Suite is running. And by default, it's running on port 8080. So if you go here, proxy, options, you see that's where the default interface is. You can change this if you have something else that runs on port 8080, or if you want to be more discrete, if you want to change it to like port 443 or something, make it look like it's just what's normally for HTTPS websites, you can change that. But for this instance, we don't need to do that. So that's set. Let's see if we're catching things. So I'm going to reload this site. And we see that the intercept is on and we're catching things. So I'm going to turn off intercept. And we're just going to look at the target. And we see already that there's a bunch of API calls. There's a bunch of REST data points that are returning information. So if we drop this down, we can see everything this way. One thing to note right away before we dig into pages of the application is that because this is Angular, a lot of the front-end application is running actually on the browser itself on your client computer. That source code isn't really clean to read, but it does have to be sent to your client browser and you can read it. So this main ES 2015, that is the JavaScript itself. And I'm not going to try to look at it in Burp Suite, but if we inspect element, refresh this again. This is the source code that runs that client application. Now, of course, it's minified. It's hard to read everything in this language, in this kind of format. You can put it in a JS prettifier. It'll properly indent things. It'll try to rename some stuff to make it easier for you to read. Really, when I'm looking at this at the first run, I just want to see if there's anything that sticks out. If you do Control F, you can search for certain keywords that don't really change. So for example, path is used in the router a lot to kind of tell you where certain URLs are for the application. So this is highlighted here saying path, window location, path name. That's not what we want. So we're just going to keep clicking through. Now there are 42 instances of path. So we're not going to look at all these closely because there are crap that we don't want. But jumping down here, we see that there is path and then administration. So if I highlight this and then just go down a bit, we can see what else there is. So there's administration, accounting, about, address/select, address saved, address create. So there's a bunch under the address directory. And deluxe membership. So those are all things that we want to make sure that we look at as we go through and enumerate the application. So I'll close out of that for now. Also, I should have mentioned this when I pulled it up. This is the developer tools. It helps you inspect certain elements on the page. So if you want to see the specific HTML code for what you're looking at, it'll show up in this window. Console is very helpful. It'll show you any errors or warning messages that the application is giving you, as well as gives you access to certain functions that we'll talk about later. And the rest of these, like the network tab, is what we just looked at. This just shows you all the files that is being loaded in your browser. You can also look at storage and see things like cookies and session data. All this is what's being used to save local data. Like when you log in, you'll get an account token that says you're authorized as a certain user. All that will be shown here. So I'm going to close out of that and let's look through the application. Actually, sorry. In that last slide, I told you about looking at robots.txt and security.txt. Let's look at that real fast before we go into anything else. So robots.txt. That's not going to work because we're in the app itself. So looking at this URL before I type that, and that's all shown up from history. Don't want that. Port 3000 / that's what you would normally see when it's just an application, but we have this # again. This is how the JavaScript router is going to be processing the path further. So anything you want inside of the Angular app itself, you would tap here. Because robots is normally on the web server, we're going to go outside of that. So it's just going to be / robots.txt. I thought it deleted my history, but I guess not. So it's just going to keep popping down. So here we only see one disallow. Robots.txt is telling us not to look in the FTP directory. So of course, that's the first place we're going to look at. FTP, file transfer protocol. When we look here, oh, I don't even know what I clicked, but again, we're already seeing errors. This is telling us that we're running a Node.js server, Express version 4.17.1. So this is something you definitely want to write out for what we're catching. So we can say robots.txt has FTP, and we see that there's an error for Express 4.17.1. See if there's anything else here. Okay, so this is telling us that only MD and PDF files are allowed. So I clicked suspicious YML. I guess if we click one of these other MD files, it'll try to download it, but that's allowed versus being blocked with an error message. The other thing that looks good here is the package.json.back. So package.json is used a lot of the times in these front-end apps or Node apps to tell you what packages are being installed from npm. So you can check that for version numbers and to seeing if there's any vulnerable libraries being included in the code as well. So let's try to download that as it is. And now we're seeing that error message again. So one way we can try to get around this is we can use a null byte to try to fake out accessing a .md file when we're really not. So to do that, a null byte is URL, or for the URL is just %00.md. Now when we run that, we get a 400 error. So the issue with this is probably because it's trying to process the % in the URL. So to fix that, we can just URL encode it. So we're going to inspect the element, go to console, encode URI component, %, run that. And you see a % when it's URL encoded is %25. Probably what it's trying to do is, let's decode a URL component. If we pass %00 by itself, yeah, that's -u. Okay, so instead of 25, let's do %2500. So it'll look like this. And we see that's actually %00, so that's different. If we try that with the package.json, we actually get that download, so we don't have the bad request anymore. It's actually successful. And I'm just going to save this file so we can look at it. So hit OK. It's in our downloads. We open this up. Cool. We already see all these contributors, which is nice. All the homepage information, descriptions. But what we care about is if we go down here to the dependencies. We see all of this, all the npm packages that it's using, and some of these might be vulnerable if they're older versions or if they're just an unsupported package. So I'm going to copy this and just say there's a poison null byte. So from Taco Man, we have, would the dev dependencies array be useful too? Yeah, so exactly. This is also good. The question is whether or not the server is actually running in production mode or development. So some of these packages may or may not be on there, but definitely worth taking a look at as well. These are just additional packages that you'd also want to take a look at. Yeah. I'm gonna keep going through here. Packaged JSON. Also, I should clarify that the .bak, right, when this is a live application, won't be there. It's normally just package.json. .bak is normally just used when someone's creating a backup. They're temporarily moving files around. They will add .back so it doesn't overwrite the real package.json. So there's a chance that this is a outdated version of package.json, or it's just, a copy of the actual file. Okay, so let's go back to FTP, see if there's anything else. Now we could grab the coupons and the suspicious errors and the Easter egg, but really I'm just going to try to click through these other MD files and see if anything pops up instead of being downloaded. But I think that's just how Firefox is reading these files right now. It's not displaying them in the browser. If we go to quarantine, let's see what's in here. Juicy malware, Windows 64, Linux 64, or Mac OS. Okay, so right here, if this was a real application test and not something that was meant more for a CTF, this would be a huge red flag, and this should be where you stop your testing and go back to the client and say, hey, while I was poking around, I found signs that somebody else has previously exploited your server. This is what I found. We need to check your logs. You need to do some kind of incident response to this. Don't go any further. Don't try to do what somebody else did and copy it. Just let them know and move forward properly. But because this is a CTF, this might have been placed intentionally, or sorry, I shouldn't say CTF, because it's a training exercise. This might be here intentionally to show us that it is possible to upload malware this way, and maybe there's something specific about what they've uploaded here that we can recreate ourselves. So just a trick for next time. We might want to come back and look at this. Okay, so all right, it's already after 7:30, so I'm going to try to go through the rest of my recon quickly. It looks just by going through some of this stuff, we got some challenges done already. So error handling, provoke an error. All right, so just seeing that error message, we solved the first challenge. Forgotten developer backup, getting that package.json was a challenge. And the confidential document. I guess either legal.md or the accusations.md was a challenge to open that as well. So just by doing really good reconnaissance, we've already found 3 challenges. Gonna get that out of the way. All right, so while we continue to look through this, right, we see that there are products here. If you click on these, sorry, I shouldn't even click on the add to basket, just click on the icon itself. We see more about it. There's reviews, description. If we open up reviews, okay, so it looks like there's either employee reviews or customer reviews. And it's important to notice here, it says admin at JuiceShop. This could either be a company email or just the email that the admin uses themselves. So anytime we see something like this, we want to record it because this could be an account that we are looking at in the future. So take this and put it in your notes as well. We can go through, click on the rest of these, see if there's other reviews like this one, Bender at JuiceShop. So we can see that there's 2 accounts now that we're interested in. There's Bender and admin, none for that, none for that, but this has a bonus on it. So again, I'm just kind of looking through these, seeing if there's anything interesting that pops out. And that's about it. All right, if we look across the top here, we have the side menu. This shows us customer feedback, complaints, about us, photo wall, deluxe membership, and an external link to the Juice Shop. Now, one thing we want to take a look at here is if you look in the bottom left of the browser, it says the IP address, port 3000, and then redirect to. This could be interesting because it's not just a direct link to the GitHub repo itself, it's to the application and then redirecting. So if there's a chance that we're making the server make that call for us, we could use that later in server-side request forgery. So we can take a look at that later if we have time. Let's keep clicking through these pages to see what's there. Customer feedback. This looks like an anonymous customer feedback form. Let's see if we can leave feedback without having to be logged in. So if we give rating, result, hit submit. Thank you for your feedback. Yeah. So it looks like there is anonymous feedback. You don't just have to be a user. If we go to complaints, it looks like this is a similar setup where you have to be logged in, you have to be a certain customer, and you can type in a message. Nope. Or not. Maybe it's just default set to customer. We can attach an invoice if we try to hit submit. I don't see any error messages, so let's take a look at inspect element. We hit submit. Yeah, we don't see any errors coming up, so that may or may not be working as a feature. So there was an unauthorized. Yeah, so that was before I made the request. That might have been from something else we were doing. If we inspect element, console, if we're here and we hit submit again, each time we hit the submit button, I've hit it 4 times now, it should pop up that same error. So because it's not, I believe that error was somewhere else. Just to confirm, I'm going to go back to that main page. I think it was when I clicked add to basket instead of this to bring up the info. We click add to basket. Yeah, we get this unauthorized status text rest basket. So probably because I'm not logged in, I'm not authorized to put anything in my basket, and that's where we saw that old error message from. So I'm going to clear that again, and we'll keep looking through the application. Thank you for pointing that out. All right, so let's go to the About Us page. We'll close out of this. All right, so we see a bit about this. The first link here, this is pointing to that legal MD file in the XP directory. So even if we didn't look at robots.txt, we have this direct link here. And again, because we don't see that # / before the path, we see that it's outside of the client-side application. Definitely something that we should take note of and go investigate while we see the link. Also down here, we see other links to Twitter, Facebook. These are all external. And PressKit, Reddit, and Slack, Facebook as well. Also Twitter. Okay, so all these are direct links. So it's not using that redirect, which means we're not going to click these because that just takes us outside of the application. Also down here in the feedback, we can see other people's feedback as well. And there are either anonymous users or the emails provided, but they're kind of starred out. So as this keeps going through, oh, hello hackers. All right, so hello hackers is the one that we just posted. So it looks like there doesn't have to be any approved kind of feedback before it displays here. So the fact that we can be unauthorized and upload content that gets displayed to other people, that right there could be a sign that there's vulnerability. Also, looking at these, what's it called, email addresses here, even though they're kind of blurred out, we can see a couple of the letters if there's a max length. So we can see that there's either, like, this one's probably Bender, and the one I was looking at before it rotated was probably admin. Not Chinese hacker, hello. All right, cool. All right, so as we're going through this, that's the About page. Let's see what else we can take a look at. There's also the photo wall. So here it looks like there's 3 images. This first one is broken. And then we have these 2 here. So if we click one and try to view the image directly. We see that it's in Assets, Public Images, Uploads. Let's see if we can see a directory view, and maybe we can see that broken image directly. No, it doesn't look like it. So this is a good sign that they're being secure and they're not actually showing directory viewings. You have to guess the entire path to the image itself. So let's go back to the application and see if we can view this one directly. We can't. All right, so we're going to inspect this element. If we look at these two span classes, let me try to make this a bit bigger. We see the one that was successful is Assets, Public, Images, Uploads, and then Magnificent, and then Numbers. If we go up here, it's Assets, Public, Images, Uploads, which is the same, so that's a good sign. And then a cat emoji, hashtag Zatchicks, hashtag who needs four legs, and then another images. So it matches. The only difference is this is using emojis. And if I look at these, the special characters in either, right? Dashes and exclamation points are fine because it's being used here. But the first image here is using the pound sign or hashtag. And we already know from running Angular that the JavaScript browser has to use that character for routing. So there's a chance that this is what's causing it to break and not load the actual asset. So let's see if we can open link in a new tab. Yeah, so even if we do this, we get nothing pulled back. So even hitting this directly, it's not loading up right. So it's not just the Angular application. If we bring up the developer tools again and go to the console, well, it's nasty. I'm going to delete all the comments and encode URL components again. Have a nice day. You have a nice day too. I'm going to type in the name of this file and see what gets encoded. I'm probably just going to leave the cat alone because I don't know what that's going to get converted to. So copy this, paste this here, and enter. So already the only thing that we see changing is that hashtag. It's %23. So if we go here, %23, %23, enter. There we go. So that's the issue. There's a URL encoding issue where having it directly as a pound symbol is breaking and the image isn't loading. But if we change that to %23, it loads successfully. All right, so let's go back to the rest of the photo wall. Oh, and that was a challenge, fixing or figuring out the encoding. Cool. All right, so let's keep clicking through things. I think that was all of the side menu. Oh no, there's also deluxe membership. We click this. Ooh, right away we see object, so that's not good. That means there's something being displayed that's not done right. Maybe we need to be logged in and this will be shown. I'm not sure. So check out what is included in your membership. Deals and offers, free fast delivery. I don't think none of this is clickable. It's just saying why you should be a deluxe member. Cool. So as we go through this, there's also these buttons over here. So if we click search, that just opens up a search bar. If we do test, yeah, okay. So we see that this is just a way to search for products. Also to take note, we see that the input that we have is displayed right here as well. So anything we type in here could be shown back to you as a user. If we click application, we see that, oh, blocked illegal activity. Okay, so I guess trying to view your profile without being logged in is illegal activity. So we're not going to click that link. If we go to order and payments, if we go to order history, there's no results. Privacy and security. If we go to privacy policy, I guess that's a challenge as well. It's just reading the privacy policy. Let's go through this, see what there is. free privacy policy website link away from us. Usage data, use of data, transfer of data. All stuff that's probably really important to read through if you're actually doing this, but because it's a fake site, I'm rushing through this for time. We could log out if we're actually logged in, but I'm not going to do that. And if we had a basket, which we don't because we're anonymous, and that errors out anyway when we try to put something into our basket, that's fine. Then it also looks like we can change our language, but I'm not going to do that. We're just going to keep it as English. All right, so I think this is a pretty thorough recon. Took more time than I probably should have to go through the application and see everything that you can kind of click through, the obvious links, the shortcuts. Did I forget anything? Oh, I went right through. I only did one of the links that I talked about earlier. So we talked about robots.txt. I skipped over well-known/security.txt. So if we go here, again, that's showing you the contact information for if you, again, want to submit a report to the owners. This could be, security at so-and-so company, or in this case, mail to do not reply at OWASP JuiceShop. So other things of notice here, they give encryption. So the public key, if you want to encrypt the data that you're sending, and also acknowledgements. Right here, this is a path that we did not see in the router just by doing a quick search of that JavaScript file. So let's try to visit that directory or that part of the application. Scoreboard. All right, cool. So this shows us that we got 2 more challenges for looking at that security policy and for finally seeing the scoreboard page. So just by doing good reconnaissance, we can see that we already got 6 of the challenges that were meant to find on this training application. So this just goes to show that you don't really have to, know every exploit or vulnerability to find some pretty good, interesting details. We already have some stuff that we can put in a report or into a report, like the missing URL encoding, the fact that HTTP is being visible to anyone, that you can download files that are not Markdown or PDFs, and the fact that that backup file for the JSON package is, or the package.json is still there. So all this stuff can be written up in your report. I'm going to transition back to my slides and we'll start talking about testing. So now that we've gone through this stuff, we see that there is a bunch of different avenues that we can look through. We want to start being a little more malicious. So we found what technology this app uses. As I was describing what JuiceShop is, we know it's Angular. We have the Node.js version of Express, that 4.17.1. We have all of the libraries that are included from that package.json. Any of those could have known vulnerabilities online. So it could do a quick Google search or looking on exploit database to see if there's anything posted. We can see if there are any harmful inputs that we could use to either break the application or give unexpected results. For example, we could try to enter other URLs that we don't have, or that we don't know from looking at the JS file or robots.txt. We could guess for random things. We could try to input malicious feedback or search terms that we're going to do in a little bit, and try to get the application to do something it shouldn't be. Also, we want to see if we can access other people's data. Basically, if we're not logged in, can we see a certain user's information? And then once we see data we're not supposed to, can we modify that data or remove it? Trying to test these things are different ways to exploit that code. Yeah. All right, so looking at the vulnerabilities, another great gem from OWASP is their maintained list of the top 10 vulnerabilities. These are all things that you should look at if you're going to start doing web app penetration testing. These are kinds of vulnerabilities that, again, don't really go away. It's just how you execute some of these that change over the years. We have a comment from Ali that says, which hasn't changed in years. Actually, that's not true. So there's 2017 and 2019 that's out now. It was yearly at one point, but it just takes longer to get appropriate data. I think they're collecting data right now for a 2020 version. So
I meant that the top 10 are so common that the top 10 list barely changes. It's still the same items. They may have changed places within the top 10, but essentially the same type of injections or inefficient logging or whatever it is. These are your basic top 10 vulnerabilities seen year after year after year.
yeah, that's very true. So, websites have been around for what, the last 30, 40 years? It's probably always been the same thing where it's just how we're classifying them. But yeah, that's a fair point. The top 10 will always be the top 10. It's just, what's more of an impact than maybe something else. All right, so I'm not going to go through that list in order as we saw it before. I'm just going to go through the things that are easy to explain and demonstrate for you guys. We've got 8 minutes before the 1 hour time slot ends, but I'm going to go as late as we can until either of the streams cut out on us. So cross-site scripting, this is where you take an input that you can see and try to inject code and get it running on the client-side browser. So like I said earlier, with this being an Angular application, there's already a lot of JavaScript running. If you can do any additional JavaScript code on some of these inputs and get that displayed on the browser, that will also run on top of the application itself directly on the browser. I put a little hit here on developers saying that when they're coding, they're often trying to get the right thing to work. If you're expecting only the best scenario, you're not planning for the worst case scenario. So, for example, I mentioned that search before when I typed in test. All they care about is when you put in a search term, it gets displayed on the next page. They don't think that that input and redisplaying it could be used maliciously. So let's take a look at cross-site scripting before we go through more slides. It's a good thing we're already on the scoreboard because this makes it so I can be lazy and just copy and paste from the challenge itself. We're going to perform a DOM cross-site scripting attack by injecting an iframe. That iframe is a HTML object that's just going to execute from the source, which is running JavaScript. So all this is going to do is pop up a alert box that says XSS or cross-site scripting. So I'm going to copy that, go back to the main application, and we're going to look for places that we can paste that string and see what gets returned to us. Mentioned in the description that search is a place that we can enter information and have it shown on the next page. There's also the customer feedback form. So if you don't want to just copy and paste a malicious payload every time and see if it works, you can be a little more discreet about it and just see how characters are processed as you do requests like this. So we already typed in test and saw that got displayed back. But are things being URL encoded, or is it just being spit back out on the page? So one thing that we got stuck on before was £. Also, when we're injecting iframes, we need to use angled brackets for the tag itself. And then we can just see if there's anything else, exclamation point, @, single quote, double quote. We already know that £, should be %23. So I'm just going to throw this in or throw that in as well and see how this is all being returned. So if we hit enter, we see that it doesn't break anything, that if you look in the URL itself, the URL query is encoded. But when you see the results, typing in £, shows £, typing in the brackets shows brackets. Everything else goes exactly as it was typed in. This does not convert to URL encoding as it is. So let's try to paste in that malicious payload, which is the iframe with the alert, and hit enter. Doing that, we see it brings up this iframe box, which is in the shaded out area, and that is running this JavaScript that is bringing up the alert box. Also, we see we solved the challenge, so that's good. All right, back to slides. When you have vulnerabilities like this, you want to make sure that if you can exploit it, you also try to provide mitigation steps in your report. So there's a couple ways to do it. Some of them are sanitization and escaping. Sanitization is where you include a library that strips out parts of the input that allows the exploit to run. So in an obvious example of a script tag, which is used for JavaScript, you would strip that out of the input entirely. So that would get removed. Escaping is when you replace the important characters that are needed to run, like the angle brackets of a tag, with the Unicode examples. So it will display correctly, but it won't run on the browser. So a header tag, like we have there showing the example, the tags are replaced with alt or ampersand LT semicolon. And when it's displayed on the browser, it will just display as that less than sign, but it won't be executed. It's important to note that some of these mitigations are not perfect. Nothing's ever good. Code is code no matter what. There isn't perfect code, no matter how good of a developer you think you are, Sam. But when you're looking at stuff, it's important to see if there are ways that the library itself was implemented wrong. So for the web application, right now it does have a sanitization library. I remember when we were looking at the dependencies, right? When we paste this in here, here it is. Sanitize HTML version 1.4.2. So there is some kind of sanitation control, but it didn't block the cross-site scripting attempt that we had in the search bar. So I'm wondering if it's an old version or if there's a vulnerability for it. So let's do a quick search. If we do sanitize HTML 1.4.2, I'm going to turn the proxy off because I don't want to be scanning Google results. Okay. Sanitize HTML. Okay, so already the first two results on Google shows that there are vulnerabilities for it. If we look at sync.io, versions less than or equal to 1.4.2, which is the version we're running. Let's see what this is saying. So sanitization of HTML strings is not applied recursively to input, allowing an attacker to potentially inject strings and other markup. All right, so what that means is that the library will run and remove certain strings that it finds as malicious, but it only runs it once. So let's keep running through this report and see if we can find any examples. All right, we see there's a referenced issue. So if we click that, it's not applied recursively, leading to a vulnerability. All right, this guy provides an example, right? So I'm not harmless. There's an image source CSRF attack inside of an image CSRF attack. All right, so we don't want to be doing a CSRF attack. We want to be doing cross-site scripting. So how can we do this? We can take that iframe logic. Let me just paste it here. So I still have that on here. Okay. For the record, I'm using an old version of Joplin that has cross-site scripting on it as well. That's a known thing that's been fixed in the latest version. I just am too lazy to update. So I'm going to X out of that and break this. I'm going to use a different application to copy this string besides Joplin. Gedit, or not. Text editor. Mousepad, that's right. New version of Kali. So we have iframe source, and what they did was just post the same thing in front of that other cross-site scripting. So I'm curious if we copy this, and we already know the search bar is working without needing to double it up like this. So where else can we have a input that we can test? Clear out of that. We had feedback, the feedback form. And when we posted this, we saw that it showed up on the about page. So let's try posting the comment here. We're not even going to log in. We're going to say this is a 5-star exploit, because why not? 8 minus 10 is -2 plus 4 is 2, I hope. Yes, okay, and it says, thank you so much for amazing 5-star feedback. So we know that this was accepted. Now let's see if we get a cross-site scripting pop-up when we go to the About Us page. We might have to jump through this until we see our feedback. All right, so Hello Hackers was our first one from earlier. And then this looks like it didn't run anything. That should have been our 5-star feedback with the exploit. So that might not be the right thing that I was posting. All right, let me check my notes, see if I'm doing something wrong here. I did this earlier and I think I got it working, so I'll just, maybe this needs to be script. All right, we'll try this one more time. If it doesn't work, then we'll just gotta move on to the next one. We'll do 4 stars. This should. Can't do math when I'm under pressure. All right, let's go back to the About Us page. I wonder if any of this is running. No, so there's a bunch of error messages, but I don't see anything related to our exploit. So let's bring that down and try to see if it'll exploit. Nope. Okay, I can't get this running, so we're just going to move on to the next thing. I guess one good thing to say is we got the original cross-site scripting, but I can't get the sanitization example working. So that's something we can dig back to later. All right, going to the next type of vulnerability, there's also injection. Injection's similar to cross-site scripting, but it's been expanded to include a lot of different types of injection. There's SQL injection, where you try to include database queries in your logic. There's HTML injection, trying to include different displays and stuff. XML entity injection, whole bunch of different things that get included in this. Anytime you're putting in additional code or logic that you want the application to run, that is in this category. So specifically for an example, we're going to be looking at SQL injection. So to kind of explain it first before we just jump in and run something, Uh, let's look at what SQL queries are at first, right? So pulling data from a database, you need to use a query to get that information to the application. So for an example, whenever you're logging into an application, you're providing a username and a password. That needs to be compared against something on the server side so that they can actually verify you are the user that you're trying to log in as. To get that information from the database, you'd see something like this query on this third line. The select ID from users, where the username matches and the password matches. Logically, this might make sense, right? You're providing a username, you're providing a password. If those two things match on the database side, you'll get the user returned. Otherwise, it'll be null. What's lacking with this simple example is that there's no controls that prevent you from changing the logic of this query when it's talking to the database. So if you can somehow change this to be change the where parameter so the logic is different, you could get a different result than what you'd think. So for example, if we can say where the username is something you provide and the password is something you provide, or true, that or clause means that even if these first two things are wrong and the third thing is still right, it will return some ID. Normally when you do this or true run, it'll return the first object in the database. And in every training example I've seen so far, normally the first user is the admin user. That's the first thing that gets set up, or it's a development user, which runs as admin anyway. So look at how we're going to do that SQL injection. When we're logging in as a good user, we have a username, Johnny, and we have a long secure password that nobody knows. Secure passphrases are hard. If we want to do injection, we can change one of those fields. In this case, it's the password to any or a equals a. Having that in there with the single quotes matches the single quotes used by the query. And that literally just ends the password input field and then starts adding onto the query, and then ends with an open single quote as well to match what the application is providing. So providing that one input, you get this query down at the bottom where it matches the or true from the last thing, where username is username and password is any or equals a, or a equals a. So even if these two things are false, there's no one that has password any, there's no one with Johnny is the username, we'll still get the first username in the database. So when you're checking for SQL injection on a login prompt, there's a couple different ways you can format it. Mainly that's because different databases use different syntax in their languages. The list you see here is pretty common. You can search SQL injection online and get it. I have a link here of where I've got this quick list from. Normally when you're running these, it's good to finish your command with some kind of comment. This means that anything after the comment doesn't get executed as part of the query. So you saw here, I had that single quote as part of the query itself, and I had to match the malicious input to finish off that query. Otherwise we get an error. If you threw a comment in the end of the line, you don't have to worry about matching up single quotes or double quotes or having the right parameters. You just need to end your query and comment out anything that's on the rest of the line. So we'll do that real fast. We're talking about account logins. So we're going to go to account. Why is it saying we're logged in? All right, anyway, account, log out, account, log in. Okay, that's weird. We're going to log in as a SQL injection first. So my favorite is always just X or 1 equals 1. And then semicolon to end the command, double dash to start a comment. You saw before, there's a bunch of other ones that have different ways of doing this. We could have done #, we could have done /* to do a multi-line comment, but this is what I normally type in first before trying anything else. Now, because we have this comment, whatever we type in for the password is just going to be in the comment. So we could just do ABC. Hopefully this still works. All right, cool. So at least I didn't mess up this example. If we ignore that, we see that you successfully solved a challenge. The login is administrator. So now we are admin at JuiceShop. If we click this, we go to the user profile. So nothing we haven't seen before while doing Recon. So once you get user privileges, once you get administrator privileges, make sure you keep going back and doing more Recon. We saw when we were looking at that main.js file that there was a administration file or path. Let's click that and see what we can find. So just visiting this, again, we see the admin section. And as we wait, we see data coming in. So we see all of the customer feedback, including what we tried to submit here as feedback. And we see all of the users for this account or for this application. So copying this list, saying that there's user enumeration once you get admin, you can use all this to kind of figure out more about the application. Also, now that we have this administration pad, oh man, you can see all of these files that we're catching. Most of these are just the language assets. If we go down to REST, we see that there's this admin and user products as well. Try and see if there's anything good here that we can catch and kind of like just replay to see if we can get a list of users. Seems like it's doing pretty well. Instead of clicking replaying this, we can also just turn the intercept back on. I never turned the proxy back on. That's why I'm not catching things. Choice of doing this live. Settings, manual. Okay. If we reload the administration page, we see this intercept getting caught. We're going to forward success REST application. So I'm not sure what that is. Assets, socket, REST admin, API challenges, REST user UMI, languages. All right, so clicking through these one by one probably isn't the best. So I'm going to turn that off and see if I can find what I'm looking for. User authentication details, root. So if we send this to the repeater and hit send, yeah, I'm not really seeing anything back. All right, well, again, so I'm just kind of clicking through the burp suite to see what we're catching in the proxy that I didn't look at yet. Let's go back to the slides. Keep moving forward. All right, so for SQL injection, right, there's different mitigations that you can do. When you're writing out queries, you can be using prepared statements or stored procedures. This kind of stops logic from being able to be injected. Whitelisting certain inputs as well. Doing some kind of regex matching or comparing against the list so that only certain values are allowed to be used with the query, as well as escaping any input. So when we do single quotes or just typing or, making sure all of that isn't being processed by the database as actual query syntax, but it's just being used as a string input. Broken authentication. Okay, so another vulnerability is broken authentication. This is where either authentication between users isn't implemented correctly, or session logic is incorrect. So one example of this is having like weak passwords if something is easily guessable, or if there are poor security questions being used for like forgot password, that could also be broken as well. So I've got 2 examples for that. Let's take a look. So we know that we have the admin account, but we're not sure what the password is because we're just using SQL injection to get the account. So we can log out of here and try to redo that login as well. So if we go to, you know what, I'm not actually sure what the login is. So we're just going to turn the proxy back on, intercept, and catch the login attempt when we do a bad login for admin. So we know it's admin at juice shop. We don't care about WebSockets. And I'm just going to say password. So when we log in, we see this REST user, who am I? I don't think that's what we want. Post REST user login. So this, we see the credentials we're passing in. I'm going to right click this and send it to intruder. We're going to try to do online brute forcing and just try to guess the password. So we can turn the intercept off, let this go through. We see that password is not the correct value to use. Now, there's two ways to brute force a password. We can either find a word list. There's a lot of them online. There's SecLists, which is being maintained on GitHub. That is a massive list of commonly used and bad passwords. There's also the word list directory in Kali itself. So if you go to user share word lists, all of the tools that involve a word list, those are being stored in that directory. So you can use that to brute force, the most common 100,000 passwords and see if any of them are used with these accounts. For time's sake, I'm just going to use like 10 accounts or 10 passwords that I put into a text file. I made my own very specific word list to use, but I'll show you how to configure it. So the target is already configured for us because we put it through the proxy and just moved it to this tab. Positions, this shows us everything about the request that we could be changing. By default, everything is included as something that gets modified by the payload list. We want to clear everything. We're not changing the language, we're not changing the status or the IO or the continue code or even the email. The only thing that we want to change is the password. So we're going to highlight that and click add. Going to go to the payload and type in the sets that we're using. Right now, we're only going to use one set just for the password, a simple list. We're going to load that from text file. So again, on Kali, it's user share word lists. And then this is where I have my custom, very short, good for demos word list. If you want to use something like RockU, you can expand that into the text file and use that to load every single common password. We're going to open this. We see that it gives us 5 common admin related passwords. And that's all we're going to change. So we're going to do start attack. Because we're using community edition, it's going to be throttled, but that's not a big deal. We only have 5 requests. And going through this, we see that the second to last option, admin123, gave us a status of 200. And because we have the application in the background, we see that we solved a challenge. So I'm guessing that's the right account that we logged in with. So if we click account, nope, it doesn't matter. We're going to type admin123 and log in. So now we have the administrator's account. And by brute forcing, we see that weak passwords are used. Weak passwords, again, there's no validation saying that you shouldn't use a weak password while you sign up or set your password. And that's what we would be writing down in a report as we go. So I'm going to go straight to the other example. When you go to log in, we have this forgot your password link. All right. If we click this, we already know all of the emails because we were able to hack the admin user and get that list. From the feedback, we also saw that there's a vendor at shop. Security question, just by typing in vendor, we see that this is completed for us. So the company that you first worked at as an adult. Well, if this was a real company, you know, we would have other means of at our disposal for doing like open source intelligence to find out about this user. We can search vendor at JuiceShop, the email, and see if there's any like LinkedIn accounts associated to this, if they have some kind of online presence, if they have a Facebook page. Because this is a training application, vendor is probably, you know, something that's from, you know, recent fiction. In our case, it's going to be vendor from Futurama. So if we look at vendor, first company, job, really hope I can do this in one Google search without having it tracked on Burp Suite. So again, proxy off. I have to remember to type that in this time. We see there's a Wikipedia page for vendor. We can go to the fandom or look at Wikipedia as a whole. Probably going to go with the fandom website just because why not? We see some quotes for him. We see ads that we don't want to have shown. All right, so instead of scrolling through and learning everything about Futurama, we're going to look for company. And so Mom's Robot Company is one option. Planet Express is an option. And that's all we're seeing. All right, so Mom's Robot Company is one option. Let's see if there's anything else in the other results. Company, Mom's Friendly Robot, Mom's Robot Factory. All right, so again, we're only seeing Mom's Robot Factory. Let's see if that's correct. If we go here, please provide an answer to the company you first worked for. Mom's Robot Factory. New password is going to be test, because why not? If I could type correctly. And there is some kind of password validation saying password must be 5 characters long, but that's still too weak for modern use. Let's type change. Okay, so Mom's Robot Company wasn't right. So we can just keep going through searching for vendors, you know, first job, Futurama, jobs. Okay, so this, no, that's the page we already looked at. It was saying it's a suicide booth construction worker. So that might be good. I just don't know the name of that. So let's, yeah, okay. That's not going to help us. All right, I don't remember the page that I looked at to find the answer, but I know what it is from my notes. So it's, let me pull that up here. The name of that suicide booth construction company was Stop and Drop. So STOP-N-drop. New password test 1. Test 1. Change. Okay. So again, we were able to reset vendor's password, and that's a challenge. So both of these are examples of bad broken authentication. because weak passwords and security questions that you can look up through open source intelligence are not good. So yeah, hopefully that makes sense. We still have everyone on the call. Okay, cool. Mitigations against this, again, we want to prevent weak passwords. The latest standards from NIST saying that passwords should be like, I think, longer than 12 or 16 characters. So a lot longer than 5, which is what this application is currently using. And you also want to check your passwords against a known weak password list. So you want to be doing everything you can to prevent things like password 123, admin 123. You want to make sure that users are using unique passwords. Also, you want to limit login attempts and lock out the user when they're trying to do brute forcing. When we were guessing the admin password, if it locked us out after the third failed attempt, then brute forcing would fail. Same thing with multi-factor authentication. Having a physical device would stop both of these attacks because we can only guess the password or reset the password. We can't reset the second factor of authentication, whether that's like a YubiKey or a SMS code, something like that. Also, if we were going to do a server-side attack, making sure that's managed properly and that session IDs are stored correctly is also good to know. Okay, next one, this is similar to broken authentication, broken access control. There's certain logic that says like, you're this user logged in, you want to see your profile. This is how the application is going to receive your information and display it to you. If that's not protected correctly, you can abuse that kind of logic to see others' information or modify that. So one example of that is, again, we're logged in. Thought we were. Let's log in as the admin again. Admin at JuiceShop. We log in. We can view our basket, and I think, once again, I forgot to turn this on. Okay, so let's view our basket, and we see that there's 3 things in our basket. But what happens if we turn that proxy back on and view our basket again? So refresh this. We don't care about a Git. We don't care about socket. We don't care about success.txt. We don't care about admin or assets or socket. API challenges, who am I, languages, admin. So none of these are the specific requests that we want to edit. This one is. So we see that we're using the REST endpoint, so we're getting data from the server. Basket for 1. Now this could be basket 1, but more likely this is saying the basket for user 1 because admin is user 1 or the first in the database. We knew that from the SQL injection. So if we modify this in the proxy, change it to 2, and then let this go, turn off the intercept, we now see that instead of those 3 items we saw before in the admin's basket, we see raspberry juice. So whoever the second user is has this cart, and we're seeing it as another user. So this is an example of broken access control. Again, ways to prevent that are to just put in input validation checks saying that if you're a certain user and you're asking for my information, make sure that another user's ID isn't actually being provided in the request, stuff like that. All these checks should be done server side so that the user can't modify the logic directly. Okay, sensitive data exposure. This we actually exploited earlier. This is when we were doing the reconnaissance, right? And we found the confidential files on the FTP server. That kind of stuff shouldn't be shown or displayed. They have one good example where in the assets directory and you're looking at pictures, you don't see the directory listing, that's disabled. You also want things like FTP to be either behind a login, you have to be a certain user, or not to be displayed over HTTP at all. So let's skip over that. Mitigations, yeah, what I was kind of just saying. Anytime there's data on the server, you want to make sure that it's properly handled, follow any laws, regulations, or business needs to both determine what is sensitive in your case, if that's users' payment info, if it's personal PII, anything like that. So, every country has laws on that. GDPR, for example, that says this is how you need to handle certain data. Some basic standalones that you want to make sure everyone does is encrypting it while it's at rest and also while it's in transit. This means that when you store someone's information in the database, that database record should be encrypted. And when it's being sent over the wire between the server and the client browser, it's encrypted. So nowadays, everything should be over HTTPS instead of HTTP. Also, you don't want it cached. If you're sending sensitive data to the client's browser, you don't want that saved in like client-side cookies or any data that way. If a hacker, uses somebody else's laptop and sees that local information, they can download that, copy it, use it for their own thing, or use JavaScript to send it to another server. Also, you don't want to hold on to data any longer than you have to. You want to remove it as soon as possible. All right, so that's it for my slides. We're only 30 minutes over the allotted time. Thank you guys for sticking with me. If you want, we can spend some more time going through the application trying to solve other challenges, or we can call it here. Depends who's on the call and what you guys want to do.
I'm open for whatever people are going to ask for here. By the way, thank you for being willing to step up on the notice that you had. This whole thing caught us all by surprise and shifted around a lot of plans. So,
yeah, you're welcome. I'm happy to do this. It's always good to get some more time presenting, and I'm happy to show you guys how to do some of this hacking penetration testing.
if I didn't have a 3-year backlog of projects already, it would be tempting to get into this.
Yeah, that's always the issue, time management.
Yeah.
Cool. All right.
You guys can unmute and restart your videos now if you're still on.
Still on. What are you talking about?
There's somebody still here. That's good.
Yeah, I know, Ollie. You were never here.
Who's Ollie?
Yeah. All right. So.
All right. I'm going to go ahead and shut the stream off on YouTube, and then we can just kind of hang out and keep chatting.
All right. Sounds good.
Sam's walking in this dark glare.
The Batcave.
You got to be energy